Rates, ratios, and unit rates. The student will use multiplication by a given constant factor, including unit rate, to represent and solve problems involving proportional relationships, including conversions between measurement systems. In this unit, we'll only be looking at rates, ratios, and unit rates in preparation for solving proportions. In this unit, there are 3 vocabulary words you'll need to know. The first is ratio. A ratio is how much of one thing there is compared to another thing. An example might be seen in a recipe. A recipe might call for 3 cups of flour for every 2 cups of milk. And this is one way that we would show the ratio 3 to 2. This might also be seen as 3 to 2 or 3 to 2. Notice in this example that 3 and 2 both represent cups, and therefore it is not necessary for us to list the unit. A rate, on the other hand, is a ratio of 2 measurements with different units, and in this case we will need to list the units. For example, if you have $5 for 2 cupcakes, you would list the $5 and 2 cupcakes. I'm sorry if I'm making you hungry. A unit rate is when a rate is simplified to have a denominator of 1. So in the example of $5 for 2 cupcakes, we would want to find out how much it costs for 1 cupcake. We would put 1 cupcake on the bottom, and we would actually have to divide to find out how much 1 cupcake would cost. When you divide that, you'll get $2.50. So that would give you a unit rate, $2.50 per 1 cupcake. Let's practice writing some ratios. Miss Jones has a class of 12 boys and 14 girls. Write a ratio of boys to girls in the class. So we'll color our boys blue and our girls pink. And how many boys do we have? 12 boys. So 12 boys to 14 girls. So we have 12 to 14. And this can be simplified, and so we will simplify. 12 divided by 2 will give us 6, and 14 divided by 2 will give us 7, for a ratio of 6 to 7. 6 boys to every 7 girls. Now let's write a ratio of boys to students in the class. So again, we have 12 boys and how many students? To get our total students, we'll add 12 and 14, which will give us a total of 26 students. Again, this can be simplified. We'll divide 12 by 2 and get 6, and 26 by 2 and get 13. So the ratio is 6 to 13. Write a ratio of girls to students in the class. So we have 14 girls to 26 students. And again, we'll simplify. And that will give us 7 girls to every 13 students. Now we'll write a ratio of students to teacher in the class. So we have a total of 26 students to how many teachers? Well, we just have Miss Jones, so that's going to be to 1 teacher. And because we need to have it as a ratio, we'll need to keep it 26 to 1. If we just wrote 26, we wouldn't know what that represented. So we have 26 students to every 1 teacher. And because our denominator is 1, we could call this a unit rate. Now let's try a word problem. For every 207 pounds of waste that is generated in the United States, 45 pounds are recycled into new products. Write the ratio of the pounds of recycled material to the total pounds of waste in simplest form. Note, in simplest form. That's a reminder that we'll need to simplify once we've created our ratio. So we are asked to write a ratio of the pounds of recycled material to the total pounds of waste. The pounds of recycled material come before the word to, so those will come first. So we need to find the pounds of recycled material. The pounds of recycled material are 45 pounds. So we'll start with 45. And then it says to the total pounds of waste. Total pounds of waste are 207. So 207 will go on the bottom. And don't forget, we need to do that in simplest form. When simplifying, 2, 3, 5, 7, and 11 can help us. I see that 45 is not an even number, and neither is 207, so they will not be divisible by 2. How do we know if a number is divisible by 3? If the sum of a number's digits are divisible by 3, so is the number. 4 plus 5 is equal to 9, and 9 is divisible by 3. 2 plus 0 plus 7, which make up 207. 2 plus 0 is 0, and 0 plus 7 is 9. And 9 is divisible by 3. So we can simplify here by 3. 45 divided by 3 is equal to 15. And I don't know what 207 divided by 3 is, but I can find out. Three goes into 20. 6 times. And it's 18. Subtract and you get 2, bring down the 7, and 3 goes into 27 9 times. So we get 15 over 69. And I can see now that I could simplify again using 3. How do I know this? Again, I know by my rule for dividing by 3. 1 plus 5 is equal to 6, and 6 is divisible by 3. And 6 plus 9 is equal to 15, and 15 is divisible by 3. So once again, I'll divide by 3. 15 divided by 3 is 5, and 69 divided by 3 would be 23. Now, neither of these are even numbers. They're not divisible by 3. 23 is not divisible by 5. 5 is not divisible by 7 or 11. And so my simplified ratio, or my ratio in simplest form, will be 5 to 23. 5 pounds of recycled material to every 23 pounds of waste. Here's another one. The Alaskan moose is the tallest deer. The tallest Alaskan moose recorded was 7 feet 8 inches tall. The shortest member of the deer family is about 14 inches tall. Write the ratio of the shortest deer to the height of the tallest deer in simplest form. So we want to write our ratio with the shortest deer first and then to the height of the tallest deer. Again, we're reminded to write it in simplest form. So we'll start with the shortest deer. The shortest member of the deer family is about 14 inches tall. So we have 14 to the height of the tallest deer. And the height of the tallest deer was 7 feet 8 inches tall. Now in order to compare these, we have to have them in the same units. So we have 14 inches, and we can convert those 7 feet into inches and then add them to the 8 inches that are already given to us. So we have 8 inches and we have 7 feet. So we'll take those 7 feet, and how many inches are there in each foot? 12. So we'll take 12 times 7, and 7 times 2 gives us 14. 7 times 1 gives us 7, plus 1 gives us 8. We have 84 plus these 8 inches over here, for a total of 92 inches for the tallest deer. And don't forget, we need to put this in simplest form. So we have 2, 3, 5, 7, and 11 to help us simplify. And we can see that these are certainly both divisible by 2. They're both even numbers. So we'll divide 14 by 2, which will give us 7, and divide 92 by 2. It will be 46, but let's just have a look at it. When we put 2 into 9, we get 4. It goes in 4 times. 4 times 2 gives us 8. Put it down 2, and 2 goes into 12 6 times. So we have 7 over 46. 7 is not divisible by 2 or 3 or 5. It's divisible by 7, but is 46 divisible by 7? No. And of course, they're not divisible by 11. And so we have 7 over 46, which is simplest form. The smallest deer to the tallest deer. Now let's look at some rates and unit rates. 200 miles in 5 hours. Let's write this as a rate. We have 200 miles to 5 hours. And $350 to 5 days. Now, in order to get a denominator of 1, we'll simply need to divide. So we'll have 200 divided by 5. So we see 200 divided by 5 is 40. So that would be 40 miles to 1 hour. So we would travel 40 miles per hour. Now let's find $350 for 5 days as a unit rate. How would we do it? Again, we'll divide 350 divided by 5. And we get 70. So that's $70 per day. $70 for each day. Now you'll have a chance to practice some on your own. Write each of these expressions as a unit rate. First, do 1,500 words in 25 minutes. Pause the video and work that out now, and then check your answer. Okay, 1,500 words over 25 minutes. So we take 1,500, divide it by 25, and get 60. So that makes 60 words in 1 minute. Remember, a unit rate always has 1 as a denominator. Now try this one. 246,500 people in 1,700 square miles. Pause the video. Okay. I reduced both of these numbers, 246,500 and 1,700, by 100 before proceeding to divide. So, I divided them both by 100 and got 2,465 divided by 17, which is much simpler. When I divided, I got 145. So 145 people in 1 square mile. Keep in mind here, I wasn't just crossing out zeros. I divided both of these numbers by 100. If you're just crossing out zeros, then you might cross out zeros after a decimal, which don't have the same value as a number before a decimal, and then you would get a wrong answer. Now let's look at how unit rates apply to everyday life. We want to find out which of these two options would give us a better buy. If we bought a 12-pack of sodas for $4.25, or if we bought 1 can out of a vending machine for 75 cents. We're trying to find out the best price per unit. So we're going to put dollars, $4.25, over the number of units, in this case 12. And here we have 75 cents, or $0.75 for 1 can. So this one is already in unit rate form, and the can of sodas that come in a 12-pack will need to get into unit rate form. So we'll divide. We have $4.25 divided by 12, or top and bottom out. 12 does not go into 4. It does go into 42 3 times, which is 36. And then we subtract and get 6, putting down a 5. And we know 12 goes into 65 5 times, which is 60. And we'll keep going, and the number will continue to go on. But it is clear here that we are going to get a better buy if we buy them in a 12-pack, because we'll pay 35 cents for 1 can of soda versus 75 cents for 1 can of soda. So clearly, the better buy here is the 12-pack for $4.25. Now it's your turn. Determine which box of Cap'n Crunch is the better buy. Pause the video and then check to see how you did. Okay, these decimals went out a little bit farther than what I show here. However, we're talking about money and we're talking about a better buy, and so going out 3 places after the decimal, I'm able to see which one is a better buy. Remember, the lower price is the better buy, so the lower price would win. This one comes out to 21 cents, while this one comes out to, it would round up to 23 cents. So 21 cents per ounce will win. The 20-ounce box for $4.25 is the better buy. here we have another term to learn, a constant unit rate. A constant unit rate is where the cost per item is always the same, no matter what the size. In the example shown here, which set has a constant unit rate? That means that the price, no matter which size you buy, would be the same. So if you buy a 10-pack, you would have dollars divided by units. Okay, $2.70 divided by 10 would give us 27 cents. $5.40 divided by 20 would give us 27 cents. Notice when you're working with constant unit rates, you've got a lot of dividing to do. 30 goes into 81 two times, and that comes out to 27 cents. So clearly, we have a constant unit rate in this first example given. Notice at the bottom, these are the same. That's 27 cents. And if we paid $8.10 for a 30-pack and it came out to 27 cents, we already know that this one will come out to something different. So will it be a constant unit rate? No, it will not. And so we don't have to continue dividing at this point. Jeremy ran 3 miles in 24 minutes. James ran 7 miles in 56 minutes. What can you deduce based on the information? If you're not sure what deduce means, another way to word that would be reason. So what's reasonable based on this information? See if you can get this one on your own. Go ahead and pause the video and then check your work. Okay, if you set up a ratio for Jeremy of 3 miles in 24 minutes and a ratio for James of 7 miles in 56 minutes, and then converted each of those ratios into a unit rate, in other words, making a denominator of 1, you would have found that Jeremy would run 0.125 miles in 1 minute. And James would run 0.125 miles in 1 minute. And so the correct answer choice would be C. Both boys ran at the same rate per mile.